Hello, everyone. I am very glad to see everyone again, but maybe it's the second, no, not second, the seven times when we make this conference. And let me open our workshop, Computational Linguistics. This workshop will be continued 3 sections. And this workshop includes more than 40 presentations. Very interesting, and I suppose we will have very productive and fruitful communication and presentation. As Natalia Valerina mentioned, we have very strong reglement. Every presentation should take 15 minutes. That includes your own presentation and the question. If you would like to have more questions, you should save time for these questions. Until coffee break, we have 5 presentations, and let's start. The first presentation is Modern Ukraine Electronic Dictionaries, the problem of implementing spelling change. I suppose Victoria. Yeah. No. Zariana. Zariana, Irina. Who are going to present? I'm sorry. Please. Yeah, Irina. Yeah, please.
Okay.
We can see only your. Oh, now we can see. Thank you.
Okay. I want to present research on the topic Modern Ukrainian Electronic Dictionary, the problem of implemented spelling change. Author Зоряна Кунч, Оксана Литвин, Ірина Ментинська. The object of research is popular Ukrainian online dictionary. The subject of study is the introduction of electronic vocabulary changes following the currently spelling of 2019. The study aims to identify trends in compliance with orthographic standards based on an analysis of electronic lexicographic works. Achieve these goals involves the implementation of the following tasks: to create the simple of orthographic standards that have changed following the spelling of 2019, to choose the most popular electronic lexicography work for analysis, to analyze each lexicography source for the compliance with the specific spelling norm, identify variable forms that are recorded by electronic dictionaries, to analyze the spelling changes recorded in modern online dictionaries, identify trends in compliance with orthographic standards in the source base. The source base of the study is famous electronic lexicographic works. Research methodology we can see on the slide. The first step involves the creation of simple of spelling norm that have a change following the spelling of 2019. They are allowed on the non-alternative and variable. The second step is to choosing the most popular electronic lexicographic works for analysis. First, the criteria of volume authority and popularity and considerate. The third step is the comprehensive linguistic statistical processing of the electronic source for the complaints with the 2019 spelling requirements. The fourth step is to systematize the typical tendency found in the analysis source base regarding the presence of the typical errors, display of the variation of the proposed models use, and the regular changes approved by the latest edition of Ukraine spelling. The fifth step, the conclusion, formulation and recommendation affirm to the current spelling of 2019. Based on the processing of changes made to the Ukrainian spelling of 2019, choose that significantly affect the writing of words or creation of certain grammatic form. 12 criteria we select for the study. Among them, non-alternative 8 criteria and version 4 criteria. We can see non-alternative criteria. On this slide, we can see version criteria for version criteria. A 9 electronic dictionary present on this slide. We select for the study the main reasons for choosing an online source for analysis with its authority and popularity among users reflected in the number of the visits, as well as the volume of cover material, which is reflected first of all in the number of registered words and in the range of service that can be obtained thanks to this dictionary. We analyze each dictionary according to criteria. For example, Khairova is an online library that contains several dictionaries of the Ukrainian language, explanatory, phonetic, synonyms, etymological, phraseological. On this electronic platform, the norms are observed according to most all non-alternative criteria, and comments were also submitted with a call of section is the currently spelling 2019. In this dictionary, that one non-alternative criteria 7N and one variant 4V is not observed. Spelling norm are partially reflected. Conclusion. As our research demonstration, none of the electronic dictionaries taken for analysis has fully introduced the innovation of the current Ukraine spelling. Several electronic dictionaries, Slovnik UA, SUO, Khairova, adhere to the norms of modern Ukraine spelling, according to most of the studied criteria. However, many regularity innovations we not observe in almost the studied sources. In particular, according to criteria 4V, version ending in genitive singular ую, ая, Парижу, Парижа. 7N, non-alternative, writing website name, Twitter, мережа Facebook, 6n reproduction of long word from English, Germany, Swedish, and some other languages, CK with a Ukrainian letter key, Dickens. This may be due to the low frequency on the corresponding lexemes. However, we state the ignoring the prescription of modern Ukrainian spelling requires immediate correction. It's expanding to draw the attention of the author of electronic dictionary to the fact that they adequately and completely reproduce the spelling of tokens entered into the composition. Separately, we focus on the academic explanatory dictionary, noting that it preserves the old spelling version. We believe it would be correct to display in this dictionary all the spelling following the current norm, which would contribute the elevation of the linguistic currently of the users. That's all. Thank you for attention.
Irina, thank you very much. Thank you that you introduce yourself at the end of your presentation. I would like to ask other presenter, introduce yourself as firstly. Thank you, Irina. And now we have a little time for question. And please, I see some question, but you can ask. It will be better if you up your hand on the end of the panel of our Zoom. You can use your voice and you can use chat. And as far as I see, we can question from Salomia, please.
Hello. I have been delegated to ask Madam Metinska 2 questions by head of our Applied Linguistics Department, Olena Petrina Levchenko. So the first question is, as you have analyzed a variety of electronic dictionaries, can you clarify which dictionaries follow the changes and which less? So that was the first one. And the second, according to your research, did you choose to analyze all the changes or specific ones implemented in the electronic dictionaries? Thank you.
Okay. We can see on the slide the Slovnik UR better complains with the norm of in the dictionary, and Slovnik OCUM, by the way, modern Ukraine online modern Ukraine dictionary. If there is worse, we have minus and plus. we see minus and plus, and we see not good in OCUM. And for second question, we have choose only 20. Mine 12 mine changes. There are important and most use.
Okay, thank you.
Thank you. Do you have other questions? I have, but in order to be in reglement, I miss it. Thank you very much.
Thank you very much. I'm very nervous.
it's obviously, yeah. And next presentation, our presentation is the detecting of anti-Ukraine troll and tweets. It's very cute. Who are going to present? I can see Konstantin Veroda.
Yeah, it's
please.
me.
Please.
Yeah, I'm sharing my screen. Okay. Okay, my name is Konstantin Verodov. I'm a student at National University of Radio Electronics, and I conducted research together with Anastasia Chuprina and Ruslan Kotelnikov to identify anti-Ukrainian trolling tweets on Twitter platform. Unfortunately, a year ago, Russia committed a full-scale invasion into our country, and their aggression is not limited only on the battleground, but it also includes special psychological operations that they do it online, and they utilize different social media platforms such as Twitter in order to spread anti-Ukrainian disinformation to spoil the reputation of our country. And the goal of this research is to utilize machine learning methods to identify such trolling content on Twitter platform. The task of this research is to gather a relevant data set that will include tweets related to the war in Ukraine. We need to develop an experiments plan and conduct a number of experiments, evaluate the effectiveness of different machine learning models, and formulate summary and recommendation which model is better for identifying trolling content. Our dataset was manually gathered. It consists of 6,000 tweets. There are 3,000 of pro-Ukrainian tweets and 3,000 of anti-Ukrainian tweets. It's possible to find this dataset by visiting this link on GitHub. If somebody wants to do some other experiments. And on the right side of this slide, you can see a sample of pro-Ukrainian tweets, which is not trolling posted by President Zelensky, and this is a trolling tweet posted by a random account on Twitter. Since we are going to train machine learning models with raw text, we are going to use supervised machine learning methods because every tweet has a label to which category it belongs to. Also, we have our dataset consists of the raw text, and we are going to solve text classification problem with machine learning methods. And in order to be able to process natural text, we are going to utilize NLP techniques for it. Let's discuss a little bit more details about NLP techniques and what tools we are going to use in this research. The first step, it is text normalization. We will have the tweets and we need to remove links. We need to remove non-alphabetic and non-numerical symbols. We'll do tokenization, lemmatization, stemming, and we'll do removing of stop words. After this, when our raw text will be filtered, we are going to do text vectorization. It is a process of transforming the text into numeric representation. So machine learning models can consume this data and train to distinguish the trolling content among all content. In order to understand which machine learning model performs better, we will use precision, recall, accuracy, and F1 score as metrics and efficiency indicators. The experiments were conducted on a Colab environment using Python language. And here, as you can see, the experiment plan. We are going to, the dataset consists of 6,000 tweets. It is saved in a CSV file. Every tweet has a label to which category it belongs to. We are going to do text normalization. After this, we'll do text vectorization and we'll train different models. After this, we can obtain the results. We are going to take every model from this list. There are 4 of them: decision trees, support vector machine, multinomial naive Bayes, and logistic regression. We'll utilize different text vectorization algorithms to transform the text, and we'll do different level of normalization. So we'll try to train models with fully normalized text. We will do experiments with text without normalization and with the partial normalization. Here's the results. Among all models, the best result demonstrated multinomial naive Bayes. it is could identify right category of a tweet in 89% of cases. And the worst result was in decision trees. On the right side of this slide, you can see the visual representation of this table. You can notice that multinomial naive Bayes model as well is the most stable. So this top value and this minimum value is the result of experiments under different conditions. And for example, when we have fully normalized text and not fully normalized text, overall multinomial naive Bayes demonstrated the best result. The worst result was for the decision trees. And also it has the highest variety between the best result and the worst, and it is also the less stable for different conditions. On this slide, you can see results in the context of different vectorization, in the context of different vectorization algorithms under different conditions. You can see that some models demonstrated the best result with the text without normalization. For example, support vector machine and logistic regression gave 88% of accuracy under different vectorization algorithms. In some situations, some models perform better with fully normalized text. For example, decision trees and multinomial naive Bayes gave the best accuracy with the normalized text. As a result, we can say that multinomial naive Bayes is the best model that among all models that we used for text classification. We noticed during the experiments that text normalization doesn't guarantee the best performance, because in some situations, some models gave better results when text wasn't normalized, and also there is no direct correlation in vectorizer algorithms in context of performance. So for every model, it's necessary to conduct a number of experiments to identify under which conditions they perform better. And as a conclusion, during this research, we gathered a new data set that can be used for future researches. We conducted overall more than 20 experiments for different models, and we recommend using multinomial naive Bayes for tweets classifications. That's it. Thank you for your attention.
Thank you very much for a very actual research. What question? Please ask. I have very interesting question. Maybe it's for my opinion, is the biggest problem for your research. How are you labeling your first 6,000 tweets and continue this? How you can avoid bias for this? How you can decide where is these tweets? How you say anti-Ukraine, and where is anti-Russian? It can be biased decision. Please.
The first part of the question, how we gather the data set. We created 2 Twitter accounts, and we searched through most popular hashtags such as war in Ukraine. We visited different pro-Russian hashtags like SVO, what they use in their propaganda, and we just manually selected them. We saved the identifiers of the tweets and then saved them then pulled them from the Twitter into CSV files. The criteria how we distinguished with how we understood what tweet belongs to pro-Ukrainian category and anti-Ukrainian. It is the primary idea is to understand, is it harmful for Ukraine or not, and is it trustful, and is it truth or not? For example, when a tweet claims that I don't know, there are a lot of Nazis in Ukraine and all Ukrainian are Nazis, this is definitely is anti-Ukrainian. When, for example, a tweet from some authorities of Ukraine, for example, from President Zelensky, it is most likely pro-Ukrainian. If it is from Russian embassy claiming that we commit war crimes, this is most likely anti-Ukrainian. And all tweets are in the context of the war in Ukraine.
Yes, thank you. But I suppose if you show you research for some foreign science, is this question is not satisfied, because this answer is not satisfied them, because they decide that if you choose some other expert from Russia, for instance, this expert can decide by some other way. Yeah, I agree with me. And I have some additional questions. I have 4 minutes for you. Are you, or maybe students around you, participate in some fighting for Russian anti-Ukraine tweets, for make some hackers company, because you are from radio electronics?
No, I don't know about such activity.
It's very pity. Yeah, thank you. Do you have some other question? Someone? No? Thank you very much, Konstantin, for very interesting presentation.
I'm sorry, I could, if you don't mind, I would.
Please.
Yeah, Konstantin, thank you for your research. I was wondering if you could find any insights on where geographically maybe, or to whom belong the channels, except of obviously Russian channels, who spread this trolling and propaganda and so on. So maybe in which Western countries such channels, such accounts may emerge more often?
Unfortunately, it's not possible from the it's for me and for rest of people like you, it's not possible to identify to which country the account belongs to. Because you don't have details of inside Twitter, and only a Twitter company can identify the IP address from which country the requests come from. People and users can specify manually the country or location, but it's possible to to put their misinformation. For example, I'm from Ukraine and I can say that I'm from France and create an account that behaves behind France. The idea, there is no problem when, for example, some people have other opinion in context of the war of Ukraine. For example, if they have anti-American or something, other ideas, the idea is to understand, is to find farms of bots that just spread disinformation. And the idea of this research is to find accounts that most likely don't belong to real people and just behave as trolls. Unfortunately, for our level of understanding, it's not possible to identify to which country the account belongs to, because usually it is operated by some government, and they invest a lot of money to create a firm of accounts and just spread some information. When I was gathering the tweets, I noticed a lot of different accounts that belongs to different countries. They just copy paste the same text. And the idea is to somehow to identify that this account most likely doesn't belong to a real people, to a real person, and you shouldn't trust it.
But sometimes this
I see, thank you.
account alone to belongs to real people.
Yeah, and yeah, okay, thank you.
It's very interesting discussion because it's a real problem to misinformation detection in the real world. Thank you very much. Thank you. And now we go to the next presentation. But I would like to person who ask question introduce yourself too. Is it possible? It will be more interesting for us. Now we have next presentation, a register distribution of English that touches not finite, not verbal, with explicit subject constructions, corpus-based and machine learning approach with R. Please, who are going to introduce?
I will introduce. Yeah, I will introduce the presentation. My name is Victoria Zhukovska. Okay, can you see the slides?
Yeah, we can see.
Okay, greetings to the conference participants. I'm very honored to present at this year's conference, and I would like to extend sincere gratitude on behalf of my co-authors, Alexander Masyuk and Solomia Buk, for the organizers of the conference, for the chance to participate in this prestigious scientific event. So to your attention are the results of our research on registered distribution of English detached non-finite and non-verbal with explicit subject constructions carried out from the perspective of a corpus-based and machine learning approach. Our study focuses on a particular class of non-finite and non-verbal English clauses, such as presented in the examples on the screen. For example, her eyes growing perceptibly wider, hands in pockets, with thick spectacles perched, despite oil being the lifeblood, what with her mother being immaculate too, and so on. Researchers from various linguistic trends in schools, descriptive grammar, generative grammar, corpus linguistics, and many others among them, have repeatedly drawn attention to these clauses and conventionally regarded them as rare, archaic Latinisms, which are mainly used in official discourse and written speech. In our research, we develop and test an integrated quantitative corpus linguistic and machine learning approach to investigate the registered distribution of all types of these clauses, such as non-augmented and augmented, with augmenters with, without, despite, and what with, non-finite and non-verbal clauses with explicit subject in present-day English. With this in mind, we undertake a quantitative corpus-based analysis first, which is carried out on the materials of the British National Corpus, and second, we assess the possibility of occurrence of these clauses in present-day English registers on the basis of a machine learning model. The study is based on methodological and theoretical foundations of the new framework of contemporary grammatical studies, namely cognitive quantitative construction grammar. This framework is built on the synergy of theoretical tenets of cognitive linguistics and constructionist approach and methodological principles of quantitative linguistics, quantitative corpus linguistics, automatic speech processing, and experimental linguistics. I would like to stress that from the perspective of this new framework, the language is seen as a repertoire of constructions which are considered to be form meaning pairings, and these constructions are meant as holistic semiotic models for language representation, both syntax, morphology, vocabulary, and so on. So the constructions of the language are stored in a constructicon, which constitutes a taxonomic networks of different constructions. And a comprehensive account of a specific construction is possible on the analysis of interrelated parameters of its form and meaning. So namely prosodic, morphological, syntactic, semantic, and distributional, and many other parameters. From the perspective of the framework, we consider detached non-finite and non-verbal clauses with explicit subject to acquire the status of grammatical constructions, which we nominate detached non-finite, non-verbal with explicit subject constructions. Asyntactic structures, which include a non-finite and non-verbal clause, these constructions belong to the class of syntagmatically complex clause-level constructions. So the analyzed constructions constitute a taxonomic network in modern English, and every node here represents an individual type of the construction. The given taxonomic network is organized around a constructional schema, which is macro construction. The characteristics of macro construction are further inherited by meta constructions, which are less abstract, and further acquired by individual micro constructions. As micro constructions are the most significantly rich patterns, they serve as the basis for further linguistic and quantitative analysis. In this study, corpus linguistic and quantitative analysis is carried out on a sample drawn from the British National Corpus, and the database for our research constitutes 11,000 tokens of the analyzed constructions. The analysis of the registered distribution of the analyzed construction is carried out on the example of the parameter, registered distribution parameter, which is embodied in the following factors such as spoken text, fiction text, magazine, newspaper, non-academic, academic, and unclassified text. The frequency of the constructions in the corpus indicates the degree of cognitive entrenchment of these constructions in the language community and correlates with the number of tokens which are used for the representing the corresponding parameter or factor. So the verification of the data received on the material of the British National Corpus and the establishment of statistically significant indicators, we used a three-stage linguistic quantitative procedure, which involves the use of three statistical measures, such as multivariate analysis of variance, one-factor analysis of variance, and Yuki's multiple comparison method. The obtained results are used to build a machine learning model by applying linear discriminant analysis to predict the registered distribution of the given constructions outside the British National Corpus. All quantifications are performed using the statistical data analysis platform R. So a quantitative corpus-based analysis of registered distribution of the analyzed constructions on the first stage presupposes that we established statistically significant differences in the use of the analyzed constructions in the corpus registers. And these statistically significant differences are measured using MANOVA test performed in RStudio console. The results of this test show that the differences between the microconstructions within the analyzed parameter are significant. And they are very important for distinguishing the prevalent spheres of their usage in the corpus. So the second stage of the analysis is aimed at the examining of the impact of each of the factors within the register distribution parameter on the analyzed constructions. For this purpose, ANOVA test is carried out. The results of ANOVA test indicate statistically significant differences among the microconstructions based on the factors such as spoken, literary, magazine, newspaper, and non-academic text. As ANOVA only indicates the presence of differences, but doesn't specify where these differences are best manifested, the third stage of our research requires the application of the Yuki post hoc test. So the Yuki multiple comparison test shows statistically significant differences in the factor spoken text between two pairs of constructions, namely with and despite augmented constructions, and between with and what with augmented constructions. While in the factor literary text, we see the differences between 6 pairs of constructions, in the factor newspaper text and academic text between 4 pairs of constructions, and in the factor magazine text and factor non-academic text between 2 pairs of constructions. Moreover, among the constructions, the greatest statistically significant differences are observed between with and without, despite and what with augmented microconstructions. So the indicators for with and what with augmented constructions differ in all of the specified factors. For constructions with augmented and despite augmented constructions, these microconstructions differ only in one factor, namely academic text, and microconstructions with and without augmented constructions do not differ in the factor spoken text, but they have statistically significant differences in all other factors. So based on the results of this three-stage procedure, we statistically prove that certain registers have a greater influence on the occurrence of the analyzed constructions. That is, some microconstructions tend to occur more frequently in text of certain registers and than in others. At this point of our research, a question arises. Can these differences, can the established register distribution differences of the analyzed construction be extrapolated beyond the corpus? To answer this question, the data obtained in the quantitative corpus-based analysis are subjected to machine learning modeling. The machine learning model probabilistically predicts the distribution of the analyzed constructions in present-day English usage. The linear discriminant analysis is used first to build a model for classifying these constructions, and second to identify the variables, that is factors, that contribute most to the separation of these constructions. The conducted classification of the microconstructions is reasonably accurate. The overall efficiency of this machine learning model is quite high. Therefore, it can be used to predict the occurrence of these constructions outside the corpus registers. So the obtained data demonstrate that the model is more effective in separating between with augmented and non-augmented constructions. Less effectively, it classifies despite and what with microconstructions, and less effective to separate without microconstruction. Such factors within the register distribution parameter as in classified text, newspaper text, non-academic text, fiction text, magazine text, and academic text have the most weight in separating the microconstructions. As can be seen from the data of linear discrimination analysis, a clear distinction exists between two microconstructions, specifically between with and non-augmented constructions, lending to the credibility of Tukey's a posteriori test we have performed. Therefore, it is reasonable to assume that these microconstructions will be distinguished similarly in the investigated registers outside the corpus. However, it is necessary to consider the difficulty of distinguishing between despite, without, and what with constructions, which reduces the accuracy of the suggested model and prevents us from drawing conclusions about the model's overall efficiency for the entire language. To address these limitations, we consider that additional research is required, such as the construction of a new EDA model with a larger sample size or the implementation of the alternative method. So the findings of our research provide compelling evidence for the applicability of the integrated quantitative corpus linguistic and machine learning analysis for investigating the linguistic behavior of complex clause-level constructions such as English non-finite, non-verbal with explicit subject constructions. The results of our research refute the prevalent view in modern English grammar that these constructions have a limited scope of usage, and we prove that these constructions are more productive in present-day English, and they penetrate into informal and formal discourse. Of course, the findings of our research show the need of further research, and the elaborated integrated computerized linguistic and corpus-based strategy will be used to analyze other parameters of these constructions, and they will help us to analyze the taxonomic network of detached non-finite and non-verbal constructions in modern English. So thank you very much for your attention, and I'm ready to answer your questions, dear colleagues.
Thank you very much. Unfortunately, you take all your time, but we have time for one question. Who would like to ask more than other, please?
Yeah.
Konstantin, please.
No, it was collapsed.
I'm sorry?
Sorry?
I
don't
use
have
different
question.
emoji. I don't have questions. I just
it's other emotion.
yeah, it was collapsed, not voice.
Impressions.
Yeah.
Okay.
I have some question. It's maybe a very specific question. But as I say, no, British National Corpus is not open resource. It's closed resource. You can't use it, or how it will be possible for you.
Yes, thank you for your question. Frankly speaking, the British National Corpus is an open resource. It simply gives you restricted access. And for example, if you are a student or if you are a researcher, but you have not confirmed research status on the Corpus website, you are given at least 20 tries per day to use the Corpus. But I am an affiliated researcher. I have some publications, and I have some experience of using this Corpus, and I have quite a big a number of trials every day. Moreover, I purchased the license, and the developer of the Corpus, Mark Davis, was very kind to give a free access for Ukrainian researchers for the period of war, just for 2022. But this license is extended even for 2023 for me. That's why I can use it as many times as I want, and I use it with my students as well. I share my just opportunity to use this Corpus, and that's why it is restricted, but still it is possible to use quite.
Yes, thank you very much for your honest answer. It's maybe engage some of us to take part to study this Corpus. Thank you very much for very interesting research.
Thank you, colleagues. Thank you.
And the next presentation, I would like to ask Galiya Yubataeva. She is our guest from Kazakhstan, and her research is close for me. And please, Galiya, please.
Hello.
Ask you. Yeah, we can hear and we can see.
Hello from Kazakhstan. My name is Bataeva Galiya, and I'm happy to present our research on the topic creating a thesaurus, crime-related web content based on a multilingual corpus. And this research has been conducted by Galiya Bataeva, Urkem Amarbayev, Nina Khairova, Nina Rizun, Sanjar Sultanberdali, and Kurolay Muksina. The issue of creating software tools and the mechanism to assist in the detection and the prevention of criminal activities through online textual information remains a major challenge today. The problems considered in the framework of this study are the need to identify digital traces of potential terrorism, extremism, and the other illegal and the violent actions in the internet content. The need to take into account the semantic component of the text while determining its belonging to illegal content, the lack of an ontology in the subject area of illegal internet content for the Kazakh language, as well as the absence of such ontologies in the open access for Ukrainian, Russian, and English, and the lack of efficient algorithm and software for automatic generation of ontologies based on text corpora. I have highlighted this problem because this study is aimed at solving it. Criminal investigations involve the collection and analysis of large volumes of data from various sources. In order to make the automatic processing of text more qualitative and reliable, it's necessary to use knowledge both about language and about the surrounding world. Knowledge about the world can be represented using ontologies, systems of concepts for which relations are described and the inference rules are given. To achieve this goal, it was planned to use an integrated approach. We have developed a parallel Kazakh-Russian corpus and a multilingual corpus, including text containing crime news, and the thesaurus crime-related web content for the Kazakh, Ukrainian, Russian, and English languages. which has a limited size and the structure developed in XML format, and the Flask-based web application that generates ontologies using the entry library. In this study, in order to extract specific lexical resource from the text for the multilingual ontology being created, two corpuses dedicated to criminal topics were used. The first multilingual corpus includes text in Russian, Ukrainian, and the English. The text in Ukrainian will automatically download from the official website of Ukrainska Pravda, as well as from the website of Glavcom. The Ukrainian subcorpus contains 3,147 texts. The text in Russian were obtained from the news website Redpost, Kharkiv socio-political regional publication, namely from the section Crime and the Incidents. This part of the corpus contains 5,506 texts. The English language texts were obtained from the Corpus Christi, Texas newspaper Color Times, crime section. This subcorpus currently contains 300 texts. The development of this corpus will continue in the next phases of this study. The second multilingual corpus, which is used as a base for ontology generation, is a parallel Kazakh-Russian corpus. Expansion and the addition of this parallel corpus was carried out by parsing for new sites of the information internet space of Kazakhstan, Zakon.kz, Karavan.kz, Lenta.kz, Nur.kz. At the moment, the volume of parallel Kazakh-Russian corpus contains 3,000 texts in Russian and 3,000 texts in Kazakh, including 2,000 texts with aligned Kazakh-Russian sentences. The basic source of illegal internet content ontology generation as a developed parallel Kazakh-Russian corpus, which includes texts containing criminal, news, and the web application of multilingual basic ontology illegal internet content. The basic vocabulary of the thesaurus was obtained manually from crime texts in English, Ukrainian, Kazakh, and Russian. 7 basic thematic categories were selected. They are movement, traffic accident, injury, offense, arrest, trial, and the police department, which allowed making the thesaurus narrowly thematic. This choice of categories is conditioned by the subject matter of the information resource used to fill the thesaurus. The investigated criminal news items are mostly related to the 3 criminal areas: police, transport, crime, and their subtypes. The thesaurus includes nouns, verbs, adjectives of the 4 parts of speech. Figure shows the structural diagram of the developed thesaurus, whose XML document includes 3 main elements: nouns, verbs, and adjectives, which in turn includes child elements term. Each term element represents a word of this part of speech and its synonyms in English, Ukrainian, Kazakh, and Russian. In the corresponding child elements lemma and the synset. The domain element of the dictionary denotes one of the 7 thematic categories related to crimes and the illegal actions. Each element specified in the term represents a word of the given part of speech with its synonym, synset. Definitions, examples, hyponyms, and the hyponyms and the hyponyms in the 4 language represented by the XML child elements. This figure shows a fragment of thesaurus, which currently includes about 600 main words, about 330 nouns, about 107 adjectives, and the 168 verbs, and the more than 2,500 synonyms of main words. The thesaurus will be supplemented in the next stage of the study with an extended use of bigrams. This study presents the development of a crime ontology based on the Flask web framework and the entry library. The Flask web framework is a lightweight web application framework written in Python. It's commonly used for web development, including the creation of RESTful APIs. The entry library is Python library for working with 3 data structures. It provides an easy-to-use API for creating, navigating, and modifying 3 structures. The Flask web framework was used to create a web-based interface for the ontology. The interface allowed users to browse and search the ontology and to add, modify, and delete ontology elements, the entry level was used to manage the ontology's hierarchical structure. Capabilities of the web application with ontology visualization are domain search, multilingual search by keyword, and the 3 depths. The following the developed web application shown in this figure has an interface that allows full visualization of the contents of the thesaurus. Dictionary preprocessing. This study presents an algorithm for processing data from a raw dictionary file and transforming it into a JSON format file that can be used for further analysis. Initialize. The first step is to load all necessary libraries, including the library for working with XML files. Then the raw dictionary file is located and opened. The next step is read the data from the raw dictionary file and transform it into a format that can be processed by the algorithm. The algorithm search for specific attributes in the data using the architecture process tree. This might involve searching for specific keys or values in the data, or using a more complex search algorithm to find the desired attributes. If attribute is found, then insert needed attribute. If not, set none. The algorithm search for the target attributes in the data and insert the relevant information. This might involve searching the specific keys or values in the data, or using a complex search algorithm to find the desired attributes. Export document to JSON format file, which will be processed by either functions in further steps. Finally, the algorithm exports the processed data to a JSON format file that can be used for further processing. Launching the web application. The web application has forms with fields used in the interface. Here you can see the main request page and the search result page. The result obtained, certificate of inclusion of information in the state register of rights to object protected by copyright. And at this stage of the work, basic terminological thesaurus for illegal vocabulary of Kazakh, Ukrainian, Russian, and the English language was developed. Expanded corpus of criminalist significant text of computer-mediated communication was developed, and the Flask-based web application for ontology generation using the entry library was developed. The web application is also freely and publicly available at this address. When using the web application, please provide a link to this article. The next stage of the study is to continue filling the existing thesaurus and the corpus, balance the vocabulary for all languages, add French, add first element collocation, expand the thesaurus with synonyms, add the transition function between attributes, and to continue to work on the interface. Thank you for your attention.
Thank you very much, Galia. Very beautiful presentation, very interesting for me, special. Do you have any question, Dmitro? Yeah, please.
Dmitro Dashenkov, as you said, that we should introduce yourself.
Yes,
my question is, thank you for your presentation. Thank you for your work. It's very deep, it seems. And my question is did I get it correct that you only used crime news sites, so basically news texts for the whole corpus, and didn't include any sort of general purpose Wikipedia or book texts or anything like that? Is that correct?
Okay, thank you for your question. Yes, we use crime-related websites, new websites. But in the future, we want to use policy reports, or maybe we will use maybe Twitter news, or Twitter documents and so on. And our two corpus at this moment, one of our corpus includes only news websites. So
Yeah,
Thank you very much.
I can
Thank you.
add a little as source. Yes, I agree totally with Galia. We use only web news, but it's a little different than some others. It's a little different than Wikipedia, for instance. It explains something. But we came up with ideas, studied or handle the some stories about the crime, but not we didn't have some. What is this? Thank you. Thank you. We don't have time for other questions.
Okay.
Thank you, Galia. Thank you,
Thank you.
Dmitro, for your question. And then we have presentation by Dmitro. Yeah, data set for NLP enhancing image classification.
That is correct. Can you see my slides now?
Yeah, we can.
Okay, great. So my name is I'm sorry. My name is Dmitro Doshenkov. I'm here to present. I'm a PhD student in Kharkiv National University of Radio Electronics, and I'm here to present a work that I co-authored with Kirill Smelyakov and Natalia Sharonova on a data set for image classifications, which is enhanced by NLP models. The goal of the research is to join the advancements, recent advancements in natural language processing and make it so that it can work for image classification. The goal of this particular work is to create a data set as a proof of concept for this idea, make this data set such as that can be later train more complicated models and ensembles on it, and test this data set, test the whole multimodal approach with a simplistic task that we can figure out in a simple experiment. Here, without further ado, introduce an ImageD dataset. ImageD dataset contains image data and text data. Image data is gathered from the open images dataset, which is on and of itself is a open dataset containing many images. If I'm not mistaken, 9 billion images with different labels and different kinds of labeling for different particular purposes. The images are general purpose. They don't serve specific cases, but they all contain some kinds of objects that we can process and classify. The image data set is labeled by humans. Human operators are never perfect, and sometimes the data is mislabeled. On this slide, you can see an example where one animal is labeled as both cat and the lynx, which is not correct, obviously. Let's talk about text data. Text data is sourced from Wikipedia articles. In our dataset, images are split into classes. Each image can have multiple classes, which means that there are multiple objects present on the image. In order to source the text data, we find the Wikipedia article which fits the name of the class the most. For example, for the class cat, there is this Wikipedia article that's called cat, and we source it. How do we source it? We take the image, take the article, grab the first couple of paragraphs of it, and then process it, tokenize it, so it doesn't contain any markup, any sort of garbage that we don't really need for text processing. This is done because we want to define what is the name, what does the name of the class mean.
And the Wikipedia first couple of paragraphs do exactly that. They provide the definition. So later we're referring to these text data as text definitions or class definitions. So the structure of the data set is seen on this slide. Each image class has only one definition, but each image class has multiple images, and one image can also have multiple image classes, which to iterate means that there are multiple objects of different classes on this image. So let's try out the approach that we're trying to apply here, and to verify the accuracy of matching text to images, we will build a simple working model, and hopefully, ideally, we want to let the errors of human labeling cancel out, so that we can gain more accuracy, more performance out of this classification model than we would just get out of a model trained on simply open images dataset. This is the model we're talking about. The model is a tagging model, so we want to tag each images with a few one-word simple tags that describe this image more or less accurately. These tags will not classify all the objects that are present on the image. Instead, they must highlight the main ideas that the image might conduct. So in order to build this model, we took the ResNet pre-trained model, which is quite a good model on itself, and it was pre-trained for image classification. The last layer of the fully connected head layer of the model is replaced, and replaced by our own fully connected head layer, and which feeds to a sigmoid activation. And this layer outputs the probabilities of each tag being present on a specific image. So as you can see on the slide, we took 10,718 tags just by statistical cutoff that we figured out that this is a sort of a amount of tags that would not pollute the data too much. And yeah, so let's look at what the results of the model training might be. First of all, I would like to point out that every output for every image we generate 4 tags, which is just another cutout, just another hyper parameter. We can change that, and but this is sort of a adequate value we found out. So the image here is tagged as animal, bird, water, and street. First 3 are more or less self-describing, and the third is probably related to the fact that the animal is outside, and somehow it's connected to the concept of a street for the model. The next result is an example of a negative result, which, as we see it, did not produce an accurate output, which sees those fish in the aquarium and places them in a sea or in an ocean, and also thinks that somehow there are mammals on this photo, which points out that the model doesn't understand the different semantics between fish and mammals and oceans and different bodies of water, which is sort of to be expected from this particular simplistic approach. So the achievements of this particular work is are several. First of all, we generated an overall successful approach to data collection and reconfiguration. To be precise, the trick with finding text descriptions for image classes, which I think is quite valuable. The model that we performs adequately in image tagging, and maybe it does not beat the standard image tagging some sort of a high score models, right? But that's wasn't really the goal here. And we conclude from this that the image and text data is paired adequately, and the data set has a value on itself, which is what we're really here for ultimately. What further work can be done for this with this idea is we always need more data. There is always room for improvement. There can be, for instance, there can be several sources for text definitions for several image classes, which also could improve in the future. Could improve the overall performance of the model. Unfortunately, human supervision is also still required for both image data and text data, because sometimes we want to filter out less productive images, which are maybe postcards, maybe some internet images, maybe drawings that we don't really care about for this particular research. And text data as well is sometimes not the best, and sometimes we must process it manually just to make it so that it can output the best results for the models. So to sum up, we propose the approach that we propose allows us to gather more data, multimodal data, which is fantastic, with much less effort than we would need in order to label every single image with text descriptions. Also, there are some technical advantages to this approach. For instance, if we're talking about model ensembles with NLP model and a vision model, then NLP model must work much less than it would be forced to work if we labeled every single image with a unique text. And lastly, there are possible gains for future learning tasks, particularly for image processing, where we can compare image classes simply by comparing their descriptions and generate probable much more accurate results straight away without no learning or learning with very few examples for the classes that we haven't yet seen in the trained dataset. The negative sides of this approach, of course, are that we still get less information than with the traditional approach of describing each image individually. So it would still probably output a bit more precise results. And of course, the fact that we still require some human supervision, despite the idea of automating a lot of steps of image preparation. Thank you for your attention. If you'd like, I would answer your questions gladly.
Thank you very much for very impressive presentation. Any question, please? We don't have a lot of time, but maybe brief question. In order to ask questions, it's necessary to understand what you describe. Do you have any questions? I have some brief questions. What do you know about the technology that use Google, for instance, when we're looking for some photos or some image, when we ask for some during querying and then receive return the pictures, I suppose, or images. I suppose they use the same technology because this image usually put on the website when these keywords are used. What do you think about this? What do you know?
So image search is a quite interesting task, which is it's very big. I think that at some point the most simplistic way to do that is not to look at the image at all and just to look at the text surrounding the image, which is simplistic, and it fits the simpler algorithms of searching through text versus an image versus images. But of course, we can search through images as well, and I suppose that when a search engine such as Google indexes web pages, it definitely tags some the images present on the web page with some text labels, or probably vectors, multi-dimensional vectors. Which are some sort of an internal representation of a concept in their system.
Yeah, thank you very much. Thank you, very interesting. Unfortunately, we can't continue discuss during the coffee break, but now we have coffee break. Thank you, every of us, for the join for this part of our what is workshop? Our workshop. After 15 minutes, we continue our workshop. Yevhen Kupriianov is going to be moderator. I invite you join for the next part, and thank you very much. Have good coffee break. Unfortunately, not real. And thank you everyone who made the beautiful presentation on this part of our workshops. Thank you.
Thank you for hearing out.
Yeah.
Thank you.
See you next part.
So, see you after.
Ви можемо зараз не відключатися, так, а прийти.
Hello once again.
Hello.
Let me introduce myself. My name is Yevhen Kupriianov. I will be the host of this workshop till the end. And we shall continue our next part of our workshop. And I would like to make sure of myself that some presenters are not present. So the first report will be presented by Natalia Sharonova, Irina Kirichenko, and Daria Shapovalova. Then Зоряна Галаджун, Christina Datsishin, Yuri Bidzilia, Natalia Kunanets, and Natalia Veretenikova. Is there any of you present?
Yes, of course.
All right.
Natalia Sharonova is. Irina Kirichenko is here, and Daria Shapovalova, and she will be make report. Yeah.
Okay. Let us begin with the first report, comparative analysis of instant messaging protocols and technologies for effective communication in computer-mediated environments. No?
Yes, good afternoon. Can you see my screen?
Yes, we can see it.
Okay, good. Good afternoon. I would like to present the report on topic comparative analysis of instant messaging protocols and technologies for effective communication in computer-mediated environments. Authors are Natalia Sharonova from National Technical University, HPI, Irina Kirichenko and Daria Shapovalova from Kharkiv National University of Radio Electronics. This work focuses on a form of online communication called instant messaging. The object of study is computer-mediated communication and approaches to implementing instant messaging protocols in web applications. This research focuses on different methods of implementing instant messaging and their comparison. The goal is to propose a criteria and mathematical methods to compare protocols that afterwards can be used in web development to determine which approach is preferable to use for better performance. Web applications are extremely widespread in the modern internet, and instant communication is often used to provide certain functionality in them. The study can help to determine how to better implement the technology and can save time for developers on additional research. There are different approaches to ensure online communication between people. One of them is email. Email addresses are required to register for many services on the internet, and it is generally assumed that every user on the internet has at least one email address. Another way to communicate online is through forums. Forums are an excellent source of information on a variety of topics. Users can ask questions, share the knowledge and expertise, and receive feedback and advice from other members of the community. One of the most common ways to communicate today is through instant messaging. It is a form of text-based communication in which two or more people engage in a single conversation via their computers or mobile devices in an online chat room. In its simplest form, instant communication seeks to accomplish two goals: availability and messaging. The software establishes a direct connection between users so they can communicate with each other in real time. There are several different approaches to providing instant messaging, and all of them fulfill their purpose and provide real communication between users. The main types of implementation this paper is going to focus on are short polling, long polling, WebSocket-based messaging, and server-sent events. Both short and long polling are methods that implement client pull approach. Client pull means that client initiates the update process and asks server for updates at certain regular intervals of time. WebSocket messaging and server-sent events, however, are implementations of a different approach called server push. It means, unlike client pull, that the updates are initiated by the server side, where a server proactively sends them to the client. Short polling is a type of communication between a client and a server in which the client repeatedly sends requests to the server to check for updates on the new information. In short polling, the client sends requests to the server at regular intervals, asking for any updates or changes since the last request. The server responds immediately with any new information, and the client then proceeds to process this information and sends another request to the server after a short interval. Requests are sent after regular delay and not when new updates appear on the server. Short polling is implemented using Ajax-based timer. Long polling is another implementation of client requesting updates from the server. Unlike the previous approach, long polling sends a request to the server and waits until the server has any updates to send back. Long polling attempts to minimize both the latency in server-client message delivery and the use of processing and network resources. Once the server sends a long polling request, typical the client sends a new long poll request immediately. WebSocket is a technology that allows to open a two-way interactive communication session between a client and a server. The goal of this technology is to provide a mechanism for browser-based applications that need two-way communication with servers that do not rely on opening multiple HTTP connections. Servers send updates to the client as soon as they appear, and in the meantime, client doesn't wait for a response and can send a new one. WebSockets provide a two-way ongoing conversation up until the connection is closed. They do not, however, operate on top of the HTTP protocol. Instead, they need their own TCP connection to work. Another implementation of server push approach is called server events. The goal of server-sent events is to give the browser a convenient way to receive data from the server without having to ask for it. This method allows the server to push data in a synchronous way back to the client once the connection has been established. This can be described as a one-way publish-subscribe model. The client subscribes to a special event and watches its updates once the server sends them. The main difference between WebSockets and server-sent events is that WebSockets allow to have two-directional communication between client and server, meanwhile server-sent events are monodirectional. And overall, the main implementation and the key differences are summarized in this table. And now let's move on to comparison criteria for these implementations. The main proposed factors to compare by are security and speed. Security is one of the key factors that represent how reliable an application is, how well does it handle security threats and issues, prevent leaks of data and sensitive information. In online communication, security is especially important since it defines the confidentiality of users and their conversations. Speed is an important aspect of instant messaging chats because it enables real-time communication and collaboration. Unlike emails or any other form of communication, instant messaging allows users to exchange messages quickly and efficiently, allowing for instant feedback and responses. Speed is a key factor of the effectiveness of instant messaging chats and contributes to the convenience, efficiency, and real-time nature of this form of communication. First, let's specify what security issues we will consider. For this purpose, we can use a standardized framework called OWASP. The OWASP Top 10 is a standard awareness document for developers and web application security. For each security issue, we would need to consider the following: the issue impact, numeric value that represents the severity or priority of the issue, and probability of occurrence, the numeric value that represents the likelihood of appearance of an issue. It can be calculated considering spread of this issue in web environment, as well as in this current implementation of instant messaging has a vulnerability for this issue. The proposed high-level formula can be calculated, can be used to calculate security risk, and it is presented on the slide. We can distinguish the following factors when considering speed of an instant messaging application. Message round trip time, the time it takes for a message to be sent from one user to another and for acknowledgements to be received. Server response time, the time it takes for the server to receive and process incoming messages and send responses back to the clients. Client processing time, this takes the time it takes for the client to receive incoming messages and process them before displaying them to the user. We will be considering all three of these factors to have an equal priority. Based on that, we can formulate a high-level formula to calculate the speed score that's presented on the slide. During the work in this research, we conducted an experiment to measure speed criteria of each implementation using proposed formulas. For each of the above-mentioned approaches, we created a testing environment, a small web application that supports minimal functionality of sending and receiving messages. We take into account factors mentioned before, the message round-trip time, server response time, and client processing time. In order to measure the effectiveness of each of the indicators, it is necessary to conduct initial measurements and long-term measurements. Initial measurements are those obtained when the system is first launched. Long-term measurements are the indicators measured during further interactions with the system. You can see the results of measurements for shared polling approach on the slide. We performed 4 runs and recorded time for each of the above-mentioned factors. Long-term value is calculated as an average of the consecutive runs. Using the proposed formulas, we calculate speed impact for initial and long-term performance. In the same way, we measure speed for long polling application. Results are presented on the slide. In the same way, we measure speed for the WebSocket applications. Results are also presented on the slide. And in the same way, we measure speed for servers and events applications. Results are also presented on the slide. For each of the result sets, we calculate speed impact using the proposed formula. Across different implementations, we can see that the server response time in general tends to be lesser than client processing, regardless of which site initiated the data. We can also see that numbers on the initial run tend to be bigger than those on the long-term run. In terms of speed, we can see that implementations that use server push approach tend to perform better than those using client pull. Among all implementations, WebSockets-based messaging shows the best results. On the other hand, shared polling shows the worst result by far. It can be influenced by the fact that this approach uses a fixed delay in between requests. In conclusion, this paper provides readers with an introduction of 4 different approaches to implementing instant messaging web systems. It gives us a description of what instant messaging is and what advantages it has in comparison with other forms of online communication. The key takeaways are: server push implementations tend to have higher speed than client pull ones. Client pull implementations might potentially overload the system by sending too many requests for updates. WebSocket approach tends to perform better than servers and events. However, the difference in numbers is not significant, so additional investigations might be conducted. The results of this research can be used when deciding on which approach to use when developing a new instant messaging application, as well as get a general introduction in existing implementations and their main differences. Furthermore, the research described in this paper can be continued using suggesting approaches to specify new key factors and conduct comparison using them. The proposed formulas can be supplemented with additional criteria and weight factors. The results might be used in web application development cycle, as well as expanded to other types of application. Thank you for your attention.
Thank you for your report. Anyone who has questions? Okay, let me ask you all one. So you showed a formula defining different effectiveness parameters. So your research, did your research show did the research proved in practice the effectiveness of the results you got during your research? Well.
Yes, once we used the formulas on test environments, we saw that the applications that used WebSockets performed better than the other approaches. And we also saw that in general, the client pool tends to perform worse than server push. So it's preferable to use server push approaches for better speed.
Thank you. Any more questions? All right. So we can proceed to next report. Thank you, Daria.
Thank you for your time.
Next report is anti-vaccionists and anti-vax. Linguistic means of actualizing assessment in the headlines and leads of Ukrainian text media. Presented by Зоряна Haladjun, Christina Datsishin, Yuri Badila, Natalia Kunanets, and Natalia Veretinkova.
Good afternoon. I would like to present our research results. Do you see my screen?
Yes, we can see.
1 second. Every year, the lexicographers of the Oxford English Dictionary choose the words that have made the most impact during the year. And in 2021, it was the word vax. And it should be noted that the uniqueness of the year became the reason for the nomination expansion. And for the first time, there are several such words, namely vax, lockdown, COVID-19, key workers, bushfires, and so on. And Fiona McPherson, a senior editor of this dictionary, points out that it appeared at least in the 1980s, but according to the data, it had been rarely used before this year. Researchers Patricia O'Connor and Stuart Kellerman believe that the word anti-vaccinationist first appeared in scientific literature in the early 19th century in a book review in the British scientific journal Philosophical Magazine in 1806. The concept anti-vaccinationist, according to the authors, appeared even later in the 19th century. They recorded it in the 1876 issue of the British medical journal Lancet, and in addition, they believe that the informal abbreviations such as anti-vax and anti-vaxxer appeared only in the last 10 years to refer to opponents of flu and other vaccines. The prefix anti comes from Greek, and it means opposite, opposition, hostility, and is one of the most productive negative lexemes. So anti-vaxxer is a person who opposes to use the vaccinations or regulations mandating vaccination. The Cambridge Dictionary defines the term anti-vax as it is used to describe a person or group that doesn't agree with vaccinating people and spreads and encourages opinions against vaccinations. From the various abbreviations, only anti-vaxxer and anti-vax entered the classical dictionaries as the most frequently used words in search engines. And Merriam-Webster's online dictionary lists only the noun anti-vaxxers. At the same time, Oxford dictionaries has the noun anti-vaxxer as well as the adjective anti-vax. And these dictionaries denote the terms as informal, and they don't belong to literary language and only refer to the colloquial lexical lawyers such as slang, jargonisms, and they are used by journalists to express the material, attract people's attention, or convey their position. So the connection between the title and of the journalistic material and the text emphasizes the main functions of the title. These functions are nominal, informative, appealing, emotional, advertising, attractive, and the certain requirements for the formation of the title have been developed, such as brevity, economy, ambiguity, adequacy, evaluation, expressiveness, advertising, and the combination of the elements of the title complex. However, in the text of the new media, the formation of the title of the article occurs according to slightly different rules than in the printed media. And this is largely explained by the fact that when viewing the feed of an online publication, the reader primarily sees only the headlines, which are presented in larger and bolder font, and therefore it depends on them whether the user will continue to read the news in more details or no. And the probability of reading the title is 90%, because if the reader has opened the media, then they choose materials for reading by primarily based on the title. With this purpose, the authors try to include as much information as possible in the headline, violating some rules, especially they violate the length, because a text of 12 words is remembered for 100%, and only the first 7 words of the largest sentences remain in memory. Therefore, a title of up to 12 words is considered as optimal for recognition and perception, although modern internet journalists often neglect this rule, trying to cram all its brief content into the title of the material. So lead, it is a brief summary of the journalistic material placed after the headline and before the main text, and it is an intermediate stage of the reader's perception of the information and the main idea, which is of crucial importance for the advancement of the news into the mind of the reader. And for the analysis of our paper, the headlines and lead of 3 materials were chosen that were posted on platform of the Ukrainian editorial office of Radio Svoboda, Hromadske, and BBC Ukraine. The subject is opponents to vaccination. The first article is anti-vaccination in Ukrainian myths, motivation, sources. The logical and content structure of this article, taking into account its stylistic features, is as follows. It involves a title, a lead, and 3 parts, like anti-vaccination, who are they, the most popular myth, and why is there a violation of rights. In the abstract to this material, which consists of 3 sentences, in the second and third sentence, it is observed the use of such spatial words and phrases that form a clear evaluative attitude towards the protesters. You can see these words. And having got acquainted with the first 3 sentences of the paper, the reader develops a negative attitude towards the opponents of vaccination, because they block, surround, isolate, enrich themselves, and in addition, they are guided by fiction, non-existence, fantastic ones. The use of colloquial style in the language of the media performs evaluative and expressive functions, contributes to the implementation of the dialogic speech principle, establishing contact with the reader, since the use of such words is a means of stylizing informal, casual, familiar communication. This form attracts the attention of an information consumer and is therefore quite common and quite natural phenomenon for its development. The system that we used to analyze our papers, the first one was text system, and it shows a little bit different result, like 49% of the text tonality was positive, and it can be explained as this system don't understand some phraseologism and some words with indirect meaning as negative. The second paper is politicians are anti-vaxxers. What are their chances of becoming the government in Ukraine? As you can see, the title consists of two sentences. The first one is anti-vax politicians. It's a narrative sentence combining the term and an neologism. And the second one, it is an interrogative sentence. Interrogative sentence, in the role of a title, it performs slightly different functions and questions within the main text, because their informative function becomes secondary one, and it brings to the fore the evaluative, expressive, prognostic, motivational function with the aim of attracting the audience to familiarize themselves with the material, ensuring interactivity. Such question titles contain an intriguing component, and they draw readers' attention to the proposed publication. The interrogative formula in the title of the text leaves hope for the possibility of a positive option answer, an alternative solution to the problem. And in addition, these quotation marks are an independent means of attracting attention, which emphasizes the convention of the metaphor and gives it a sarcastic meaning. Due to such selection, the reader already forms their attitude towards such politicians, and the journalism, due to the use of word both like literally and figuratively, plays with the reader, causing emotion. The lead of this publication contains 12 sentences. It has 4 paragraphs. The word anti-vaxxers appears 3 times in combination with some theses. And furthermore, the author points out to the inability of anti-vaccinationist leaders in theses, like try to appeal to councils at a different level. Also, there are some phraseological units in this paper, and they like help the author convey the attitude to anti-vaccinationist politicians. So in the chosen structure of the title, it is complicated structure, and the selection of words like jargonism and colloquial words, the author of the material broadcasts a negative attitude towards those who oppose vaccination, and the system shows the next result, like the tonality of the text is also 58% positive. And the third article that was analyzed, it is Yevhen 1000 against anti-vaxxers. What do they say about 1000 for vaccination? The title is complex. It includes 2 sentences, the second of which is a question, but without a question mark, and the lead is formed from one sentence. Popular Ukrainian names have several colloquial variants. They so-called hypocorisms, which express the familiar, friendly attitude of the speaker to the person named. And in the first part of the title, we see this hypocoristic variant of the president's name, formed by truncation of the unstressed part of the full name and joining the one irrelevant formant in the final part to this reduction. Metaphorical slang creation is a regular and natural linguistic phenomenon, as a result of which full-fledged motivated terms arise in which scientific concepts expressed by these terms are combined with real-life experience. And the sense of the process of metaphorization is to strengthen the emotional expressiveness of the language and enrich it with new lexemes that have figurative meaning. And to analyze this paper, it was used monkey learned text analyzer, and this tool shows that the results is negative, like 84%. And having analyzed the scientific literature and conducted an analysis of the headlines and leads of journalistic materials dedicated to opponents of vaccination against COVID-19, it has been found out that the text tonality on the subject of anti-vaccination is different from neutral as a rule in some informational materials, with preservation of journalistic standards to strongly evaluative ones, usually in journalistic genres. And among the main language means of expressing evaluation, it has been singled out such as the use of colloquial vocabulary, the use of phraseology, spatial words and phrases, repeats of the word, of the word like anti-vax, along with the phrases that carry unequivocally negative assessment. And the last one is metaphors. Thank you for your attention.
Thank you very much. Very interesting linguistic analysis. And now, dear participants and guests, do you have questions to the reporter? And may I ask you questions? So, anti-vax and anti-vaxxers, it means a person who opposes vaccination against,
yes.
Against coronavirus, or also any other disease?
Any other. It can be flu or any other vaccines.
Mm-hmm. And is there any Ukrainian equivalent anti-vaxxers, anti-vaxxer, for example? Is there any Ukrainian equivalent? Natalia.
In Ukrainian, we also have like anti-vax, anti-vaxxer, also in Ukrainian language.
But it's
but maybe they aren't in like dictionaries.
Maybe
in modern dictionaries.
In future it may appear such equivalent.
Yes, it may appear because maybe they are neologism and they can appear.
For example, протищепленники.
Yes.
This way. Okay. Thank you very much, Natalia.
Thank you too.
And the next report is devoted to ontological model of Helianthus cultivation in Ukrainian conditions, presented by Anna Bakurova, Katerina Vedmedeva, Stanislav Vedmedev, and Elina Tereshenko. Well, I invite the reporter.
Hello, we are from Zaporizhia.
That's nice.
Oh. Dear fellow colleagues, I plan to say a few words about information ontological model of Helianthus cultivation in Ukrainian conditions. This result was done with my colleagues Elena Terещенko and our experts from the Institute of Oilseed Crops of the National Academy of Agricultural Sciences. This Katerina Vedmedeva and Stanislav Vedmedev. He is a PhD student in our department. The experts identified objectives and factors on sunflower yield and issues on ontology competence. Helianthus culture is among the most important and economically profitable in the world, Europe and Ukraine. This is confirmed by the creation of the International Sunflower Association. The goal of this association is to develop research and strengthen national cooperation at the agronomic, technical, and legal levels. Ontologies is method which serve as a common standard for the semantic integration of a large body of plant genomic, phenomic, and genetic data. For example, PATO, pattern, is a phenotype and trait ontology. And sunflower ontology is a crop ontology, but in this pattern with number 359. Our purpose is to build an ontological model of sunflower cultivation with a focus on the agriculture technology of sunflower cultivation in Ukraine, and to analyze the need of creating such an ontology and its integration into the world agrontology system. The involvement of experts is a priority compared to the atomic method of ontology construction. The experts of the Institute of Oilseed Crops identified objectives and influencing factors on sunflower yield. You can see in figure 1. The sunflower yield is affected by a system of factors for the year, for the growing season, and the distribution of factors over the growing season and calendar year, as well as the quality of the sunflower plant genotype and adaptability to environmental conditions. In addition, the yield is also affected by soil conditions, climatic conditions, diseases, and so on, and timely control of all these factors. Based on the information provided by the experts of the Institute of Oilseed at the first step, the subject area of knowledge about sunflower soil, fertilizer, and so on, was determined, and the terminological concepts provided by the experts were defined in Table 1.
State standards and catalogs of fertilizer, pesticides, herbicides, and technologies were also used. In the second step of ontology, building, the main classes and subclasses of the ontology were determined on the basis of factors affecting the harvest, so climatic conditions and laboratory research. In the next stage, the model of the subject ontology Helianthus was built in the Protege editor and represented by the ontograph in figure 2. To determine the three root classes of the ontology, the expert statement on the main directions of research on sunflower culture at the Institute of Oilseeds, namely agriculture technology, breeding, soil selection, and genetics was used, the root classes. The basic concepts of these directions form subclasses that form the third level of the hierarchy, which correspond to certain types of class diversity. For example, the class soil contains three subclasses: mechanical composition, chemical composition, and living component of the soil. In turn, the classes of the lowest level of the hierarchy have a corresponding set of instances. For example, for the class mechanical composition of the soil, instances are considered sand, clay, and humus. All classes are disjoint, which follows from the definitions of the basic terms. The experts emphasized the need for such a factor as the timely implementation of agri-technological processes. It is important to note that the definition of on time can take place according to different indicators, namely soil temperature, soil activity levels, start of vegetation, the prevention of pests and diseases, and the total amount of precipitation for a certain period. Therefore, we introduce the time class into the ontology, which has subclasses related to the main issues of growing practitioners, farmers, who seek advice from the institutes employed from different regions of Ukraine. The example of presenting the main results of ontology developed shown in figure 3. To ensure semantic content between the components of the ontology, the corresponding relationships are superficially shown in table 2, the next slide. We have two types of ontology: quality evaluation and reliability assessment. First, semantic evaluation is based on competence questions formulated by an expert. And second is structural evaluation, is quantitative metrics of the ontograph. The assessment of the semantic quality of the ontology was carried out with experts, as a result of which many competence-based questions were formulated. You can see these questions on the table 2. The first column of table 2 gives an informal expert representation of the questions. The second column gives a formal representation using ontology class names and using first order predicate logic. The last columns list the relationships between classes. Next slide. Continue this list of questions. The presented results of the formalization of competence issues were studied and confirmed by experts in this field in Institute of Scopes. In table 3, you can see they perform a structural evaluation of the Helianthus ontology. We compare its structural estimates with the average and median values for existing all ontologies, and the same structural estimates for the sunflower ontology with number 359 from bottom. The ontology schema deepness is a measure of reliability and is calculated as a ratio of the number of subclasses to the total number of classes. Depths for sunflower and Helianthus ontologies characterize ontologies as deep. Therefore, metric estimates confirm the reliability of the proposed ontology. Summarizing the results of the analysis of the received evaluations, we emphasize that the proposed ontology is in the development stage and certain classes will be filled when working with experts. And our conclusions, our novelty is the creation of ontology model of the subject branch of sunflower cultivation in Ukraine, the experience of national experts in breedings, genetics, and agriculture technology of sunflower cultivation, as well as the state standards of Ukraine, were taken into account. The ontological model allows further integration of national resources and knowledge bases in this area, as well as the development of a unified presentation of the results of scientific research and experiments. The practical value lies in expanding the possibilities of collecting experimental data, extracting new knowledge, promptly consulting practitioners, and integrating into the global scientific community in the future. All this implies the evaluation of ontology, in particular in connection with the emergence of new varieties and hybrids with phenotype. In the course of the study, it was found that the representation of knowledge embedded in question of competence faces the task of formalizing poorly structured concepts and fuzzy relationships. The solution of this problem constitutes the next stage of research and development of ontological approaches in decision support. Thank you for your attention.
And thank you for your report. Well, so any questions? So you can ask only one question. No more questions. So let me ask such question. Is the methodology of creating such an ontological model, is ontological model applicable not only to area devoted to growing sunflowers, but any other area? Did you work out this question?
I understand you. Thank you for your question. Our ontology is a first approach to global purpose. Now it focuses on agriculture, ontology, agriculture branch, but now it consists from three roots branches: agriculture, selection, and genetics. And now it's starting stage for these branches.
Thank you. And now the next report is automatic speech recognition system with dynamic time roping and mel frequency septural coefficients by Katerina Yalova, Mikhailo Babenko, and Ksenia Yashina. Well,
good afternoon. Could you please tell me, is it possible to see the presentation?
Yes, we can see it.
Okay, thank you. So I would like to present our work, automatic speech recognition system with dynamic time warping and mel frequency septural coefficients. And automatic speech recognition allows a machine to understand human speech and accordingly implement different actions and interactions depending on the intended application. Voice recognition is a process of recognition words spoken by a person by extracting features from the speech signal and performing a comparison with a predefined database. The task of automatic speech recognition system development is a relevant scientific and practical task, the solution of which allows improving the quality of the speech, image, language, knowledge interfaces of software systems and applications. The main goal of the paper is to present the results of developing a system for automatic recognition of user Ukrainian voice commands for a graphical editor. To achieve this goal, the following design objectives have been identified and successfully completed. Development of an automatic speech recognition system model with its characteristics. Next, creating an algorithm to transform input voice command into the program commands. Development of the vocabulary for the speech recognition system. And this system implementation and testing with a high-level programming language. And also the accuracy evaluation has been provided. The automatic voice recognition system is an information system that converts an incoming speech signal into a recognized message. A model of the developed automatic speech recognition system can be described as follows. System has a limited dictionary size, is a speaker dependent, is a command system that is used to recognize separate short speech commands. The list of commands now contains 20 commands in Ukrainian language, the name of which corresponds to the name of the pictograms in the graphical editors. When analyzing an analog signal from speech, properties are extracted that are used further in the recognition process to determine what was said. The general scheme of this speech signal recognition process is next. Receiving the acoustic signal that comes from the user's microphone, digitizing the signal, obtaining the characteristics of the signal, and comparing the feature vector of the input signal with templates. The input data for the proposed systems are the user voice commands entered through the microphone. Since the system must process voice signal in real time, it is proposed to use Fourier theorem to analyze the speech signal. As a result, we will get a set of amplitudes, phases, and frequencies for each sinusoidal wave component. To restore a discrete signal from the spectrum, we use the inverse Fourier transform. To significantly speed up the spectrogram construction process, the fast Fourier transform algorithm was used, which works with the complex numbers and transformation size representing powers of 2. Relative to the main peak. The input signal was divided into intervals of 20 till 30 milliseconds, since the size of such an interval is sufficient to obtain a relevant spectral estimate. The sound signal is constantly changing, so for simplicity, let's assume that the sound signal hardly changes over a short period of time. That is why it was suggested to divide the signal into intervals of 20, 40 milliseconds. If the frame is much shorter, we don't have enough samples to get a reliable spectral estimate. If longer, the signal changes too much over the entire frame. Spectral estimation determines which frequencies are presented in the frame. It still contains a lot of information that is not needed for automatic speech recognition. In particular, it is not possible to distinguish between two closely spaced frequencies. This effect becomes more pronounced with increase in frequency. In this paper is proposed to use mel-frequency cepstral coefficients, a method that allows extracting features that an acoustic signal received from a speaker. After building the filter bank, it is possible to proceed to compare the proceeds commands with templates. After calculating the energy of the filter bank, it is necessary to calculate their logarithm, since humans do not hear loudness on a linear scale. This operation makes Mel coefficients more similar to human perception of sound. The last step is to calculate the descriptive coefficient transform of the energy of the logarithms of the filter bank. In the process of language recognition, the most difficult thing is to carry out the procedure of comparing two language elements, which are also characterized by a lag in time. Therefore, there are quite a lot of such procedures and methods. And in this paper, we used dynamic time warping, that is a pattern matching algorithm with a nonlinear time normalization effect. The dynamic time warping algorithm creates an alignment between two sequences of feature vectors. It results in a time warping vector describing the time alignment of segments of the two signal assigns a certain segment of the source signal to each of the set of regular space sentences instance in the target signal. The developed system is equipped with functions such as formation of a dictionary of announcer commands, training of the system for a specific announcer, and execution of recognized command. The automatic speech recognition system is used as a software module for the implementation of a graphical editor plugin, the use of which allows you to use the functionality of the graphic editor through your voice control commands. The developed voice recognition system has a limited command dictionary for now, aimed at recognizing 20 isolated Ukrainian command words. The developed application has the following functional requirements: the possibility of training the system for a specific announcer, because the system is mostly depends on announcer, recognition of received voice commands, and conversion of voice commands to the commands of a great editor. The presented class diagram was generated automatically within the software environment during the software implementation. To increase the software flexibility, the composition relations were implemented instead of inheritance for interaction between classes. The results of the developed program code execution is a new item displaying the ADIMS, and here you can see this a new item inside the graphical editor. After clicking the edits button, the start button is displayed, and this button activates the command recognition mode and preferences, which starts the application setting mode if it is required. The software application was tested in the following mode: 20 test commands, 10 announcers, 10 requests to pronounce each command. The sampling frequency of speech signal is 44.1 kilohertz. The resolution of speech sample is 16 bits, and the number of channels is 2. The functionality of the developed plugin is divided into 2 parts: system training with the ability to create and save a new command or a command template, and command execution mode. This part of the software is implemented as a desktop application within a Windows application form in C# programming language. By pressing the start button and starting the voice command recognition mode, it is possible to speak commands and evaluate the result of the execution. The recognition mode stops functioning when the stop button is pressed. In the program setting modes, it is possible to change the voice signal transmission device, add the voice equivalent for the command to the dictionary, analyze the sound wave and its spectrum as it is shown on the figure. In order to establish the adequacy of the proposed solution and estimate the speech signal recognition error, a transaction log was developed, which received a description of each speaker command recognition operation. Recognition accuracy values can be determined as, you can see here the formula, and the results of the conducting experiment are shown on the table. The obtained result of recognition and its comparison with the recognition accuracy of system using DTV and MEL frequency capstral coefficients allows to draw conclusions regarding the adequacy and effectiveness of the proposed design solutions. Combining different approaches allows to achieve the desired level of recognition accuracy, and the paper presents the results of the development of automatic speech recognition system using dynamic time warping and MEL frequency capstral coefficient algorithm method. The proposed system is speaker dependent, has a limited dictionary, and is designed to recognize short user commands specified by user in Ukrainian using a microphone in lifetime. The developed system is used as a program module of a plugin for a graphical editor, and to test this program we used Microsoft Word as a graphical editor. The use of such a plugin allows to control the functionality of the graphic editor through the voice commands. Application form as a desktop application to set option and record the results of the experiments, and as a plugin for the graphical reductor to interact with, for example, Microsoft Word. The average value of accuracy of all commands and recognition variants was approximately 93%. The obtained level of recognition indicates the high efficiency of the proposed solution, and also demonstrate the promise of DTV and frequency capital coefficient approaches combining for speech recognition in Ukrainian language. And it is possible to add a more command, more voice command into the dictionary and use this program with different command combination. And thank you for your attention. That's all.
And thank you for your interesting, beautiful report. So, unfortunately, we have no time for questions. Now we have a little coffee break and continue our work at 15:45 according to our program. So, and for a while you have a rest. Thank you.
Thank you. Thank you.
Well, hello once again, and we shall continue our workshop on computer linguistics. And now the next report is IT slang development of Telegram chatbot. Anastasia Medvedik, Mykola Lukoida, Zorana Rybchak, and Olga Kulina. I invite to give you word. Please switch on the microphone. Switch on the microphone, please.
Thank you very much, but I was asked to give the place for speakers for team number 3, and I will be instead of them, if you don't mind that.
Okay.
Yeah, thank you.
You are welcome.
Yes. Speaker number 3 would be me. Hi.
Hello.
May I present my screen?
Yes, sure.
Okay, 1 second. Can you see my presentation? And can you hear me well?
Yes,
yes,
we can see.
Okay. So today I'm going to present you my work on a re-engineering support and decision-making system based on Twitter analysis. And I did it with my colleagues Zorana Rybchak, Olga Kulina, and Irina Zavushchak. So, introduction to this work. Social media now have a significant impact on people's life today. And it's not only this impact whether we can buy things from social media, connect with our friends and have fun, but also a lot of people are using social media to populate propaganda or other stuff, which has a very bad impact on our social life. So when what I wanted to do with my work with my colleagues is to discover Twitter and how it operates and what influence it has on other lives. And Twitter now remains one of the most popular social network for academic researchers because it makes its data available through a number of APIs. To get this API, you need to go under some validation process, explain why you're using this data, but mostly they approve all the data usage for academic researchers. And this research is conducted to review the analytics and environment that Twitter algorithms create for the user in order to avoid spreading the disinformation and predict possible reaction of other users at posts. And it allows the development of a system which predicts the reaction to a user tweet. The purpose of the research is to improve existing methods of analyzing and supporting user decision-making when working with social networks, and also to minimize the spread of disinformation. So why Twitter? As I said, Twitter is one of the most popular social networks. Here I have a report done by Statista, which tells that in 2021, Twitter was the fifth most popular social network. And you can see on the screen that it actually stated as a sixth one, but we are eliminating YouTube because it's not like all other social networks that we are trying to compare in here. And also why I think Twitter is important is because Ukraine now is undergoing a war and aggression from Russia, and Twitter was one of the most reliable social network where Ukrainians actually could post the truth. So that's why it was chosen as a social network to do the research. And the main tasks in this work to be performed are design a support and decision-making system, train sentiment analysis NLP system, create a software, and analyze an impact and background for future researchers. So the first thing I did was to research and look through the publication based on this. And one of the most important methods of social network analysis is sentiment analysis. And actually, I read a lot of works that use sentiment analysis for social networks. So this method was a fundamental on this research too. And next is a goal tree. So here you can see the most important goal, like which one is the top on the tree, is creating a reengineering support and decision-making system based on Twitter analysis. And it was broken down to lower level goals like research and analysis of scientific literature, which we already talked about, description of requirements and system design, analysis of methods and means to solve the problem, and system implementation. Here we also have a more details breakdown, but the main goals are the one I mentioned. Then here is presented a use case diagram for a reengineering support and decision-making system based on Twitter analysis. And why UML use case diagram was chosen is because it allows to represent main use cases that the user can undergo, and also the breakdown of users by using actors, which can give everyone a high-level understanding what can be done in the system. So the next thing, as I mentioned, here the NLP, like the system for sentiment analysis should be used. And this system was chosen, like the dialogue flow was chosen to be that system. Dialogue flow, I think that it has a very big future actually, because nowadays the trends on the market are like big companies, they are trying to use small systems like Dialogflow and train as much of their staff as possible on using such things, so they can utilize it in different ways and they do not require any more of machine learning, etc. So Dialogflow, that's a comfortable way to spread the NLP through people that may not even have a scientific background. And it is also a very comfortable way to create lexicons on which the analysis was conducted. And then test phrase and results. So as I said that we were taking a look at the Ukrainian segment of Twitter, it was necessary to conduct a control testing after the dialogue flow was set, and I used a real user tweet for this testing, and the content was in Ukrainian, which is, не дивлячись ні на що ти добре тримаєшся, все обов'язково буде добре, пам'ятай про це. In English, it will sound like no matter what you're holding up well, everything will definitely be fine, remembers it. So from human perspective and feelings, we see it as a positive tweet. And if you see the results, if you take a look at the results that was produced by Dialogflow, Dialogflow also thinks that it's a positive tweet, and the intent detection confidence is 0.7. It's a good one, but it shows us that we can actually do more to train it better. But it's still sure that it's a positive intent, and it allows us to analyze more tweets like this. And then on the conclusions, as a result of conducted research, our engineering support and decision-making system on Twitter analysis was developed. And within this framework of the study, the tweets of real users were analyzed, and comparing Dialogflow results to the results of real users, they match, which means the Dialogflow is doing a great job in detecting the intent and the reaction for the user tweet. This work also provides a basis for future research in this area. For example, if we not use only lexicon-based Dialogflow, but also a machine learning to improve the sentiment analysis of social media posts, it may bring greater results and more value. So that's it from my side. Thank you very much for attention. Maybe you have some questions.
Thank you for your report. And any questions, please? No more questions. All right. So thank you. And let us move on to the next report.
Thank you.
Thank you. Next report, authored by Irina Yurchuk and Olga Gurnik. Tongue twisters detection in Ukrainian by using TDA. Well,
So, did you see?
Yes, we can see the presentation.
First of all, we would like to thank organizers for opportunity to take a part at 7th International Conference on Computational Linguistic and Intelligent Systems. Our topic is tongue twisters detection on Ukrainian by TDA. I'm Irina Yurchuk. My co-author is Olga Gurnik. So the tongue twisters is a useful part for hard talkers. It's useful for diction training, for politicians, actors, and other public people. They help them to speak clearly and cleanly. And tongue twisters help to improve two phenomena when people pronounce two or more sounds at the same time. So in practical, tongue twister detection can help us make rating complexity of existing texts and detect is it a text easy to read or not. And by using tongue twister detection, we can generate artificial tongue twisters. It helps us to enrich existing data set in order to apply more complex NLPT methods and technique. So the purpose of our work is to propose an algorithm and its realization for tongue twister detection in Ukrainian language that provides the understanding of text shape aspects with the possibility to implement it into machine learning. So let's start with some mathematical background. First of all, we have some type of structure: 0 simplex, 1 simplex, 2 and 3 simplexes. At the first, we start with a set of points, and then by using parameter epsilon, we generate some union of 0 and 1 and 2 and so on simplexes. And after that, we start to calculate some topological invariance. Briefly about such type of invariance, it's homology and Betty numbers. And homology help us to understand what is the type of structure we have. So different structure have a different numbers. And for example, Betty 0 numbers is a number of connected components, and the first Betty numbers is a number of one-dimensional structure like a circle. In our work, we use the first Betty number. So let's start to consider our algorithm. Step 1, every letter we code. We use four-dimensional space, and the first coordinate is ordinal number of character in the text. The second coordinate is ordinal number of cluster, which consists this coordinate, and then it's ordinal number of consonant or Wolf's number. So on the right hand, there is some simple picture where there are all that correspond to tongue twister Бабин бі поросцвів дощ, буде бабі у борщ, щось там, так. It in a three-dimensional space. So next step 2, we construct some structure using parameters epsilon 1, epsilon 2, and so on, epsilon k, and then computing their first Betty number for every epsilon a. It's a simple picture. We start with our tongue twisters and corresponded to a cloud of points, and then we, for every parameter, we construct a structure. For different parameters, there are different structures, and then we compute Betty numbers and obtain a k set of k numbers. And for example, if epsilon equals to 0.36, this tongue twister can be considered as a circle in a four-dimensional space. So next, last step, step 3, for these k coordinates, we use some type of classifier. So let's assume at the beginning we have a text, we code, and after that we compute the first Betty numbers, and then we put it in classifier, and then we have an answer: is the tongue twister or not? So our data sets, there are not too many tongue twisters, but we use famous one that consists 100 Ukrainian tongue twister, and then we add to them 20 and 30 non-twisters and have respectively 2 data sets. And we can see 2 experiments. Common of them is step 1 and 2. And then we use different values of parameter epsilon. In step 3, experiments 1 use a decision tree classifier, and experiment 2 we use support vector machine classifier with Gaussian. So we have to remark that we use scikit-learn library of Python. On this slide, we present our results, accuracy of decision tree and support vector machine classifiers. I would like to remark some notes that the best indicative tongue twister detection accuracy is obtained with data set 1 and test site 10%. And the tongue twister detection is stable with above average score with the following parameters: data set 1 by SVM classifier. And tongue twister detection turned out to be the most unstable with the following parameters: data set 2 with decision tree classifier. So as our conclusion, an algorithm of tongue twisters detection in Ukrainian based on consideration of text as a sample of points in 4-dimensional space, calculation of Betti numbers as topological invariance of existence of 1-dimensional circles in it, and implementation into machine learning is proposed. So we realized 2 methods of machine learning as classifier, as decision tree and support vector machine classifiers. In future research, there are several ways to improve the accuracy of detection, as well as to improve the process of encoding what's taking in account the sounds analysis, and as well as complexity of the pronunciation of sounds. And also we can consider another topological invariance in a higher order space. So thank you for your attention.
Thank you. And any questions, please?
I want to ask, how do you think, for whom is your system? Who will be users of your research?
Many some teachers who work with hard talkers child, they can generate artificial tongue twister. They can make some sentence and then detect is it a tongue twister or not, using senseless maybe in the point of Ukrainian linguistic view, but it help children to be better in their pronunciation and diction.
I see. Thank you.
Any more questions?
It's interesting. Yeah.
No more questions. So I have some misunderstanding. Olga Kulina. So you were also to present the first report devoted to
we just changed.
You swapped
some personal reasons.
But as you swapped, I will have to shift your report to the end. if you do not object, okay?
Yeah, it's also okay. So you would like me to be the last, yeah?
Yes, you put the last.
Okay, it's okay. Yeah, no problem.
Thanks. And now I would like to invite our guest, Juan from there, to present the report, Differential Microphone Array Speech Enhancement based on Post-Filtering. You are welcome.
Hello everyone, and thanks for watching. I'm a PhD from Vietnam, and today I'm very pleased to introduce an attractive topic: differential microphone array speed enhancement based on post filtering. And this article is it enhances my previous work. As we know that the demand of noise suppression is in almost speech processing application like speech recognition, hearing aids, cell phone surveillance equipment, smart home application to work anytime and anywhere, make them has the capacity of reducing the effect of annoying background noise interference or third-party pickup, and to decrease the degradation of the desired target talker in terms of the speech quality, speech intelligibility, and the single microphone or multi-microphones approach are often applied for signal processing. And as we know that today, microphone array technology is common, widely has been applied into numerous devices. And using a microphone array for ejecting the desired talker based on the construct beam pattern toward the desired talker, and the implementation of microphone array in time frequency domains is presented in this figure. And in this paper, we use a dual microphone array system with two speakers stand at two opposite direction, speaker 1 and speaker 2. And as we can see that signal model and the details microphone array differential microphone array and the two constructed beam pattern toward the speaker 1 and toward the speaker 2. And in this contribution, I suggest using a post filter, which based on the estimation of noise power and based on the MMSI estimator, is used for estimation of spectral gain, where the a priori and the posteriori SNR, which you the information a priori information differential microphone array. And the experiment as we can see that the waveform of the original captured on microphone array and the waveform of the processed by the my previous work research, and the waveform of the waveform of the processed signal by using the additive post filtering. And in figure 10, we can see the energy of microphone array signal and the processed of the outer previous work, and the using the adaptive post filtering. And we can see that the advantage of proposed method is noise reduction, and consequently the speed quality in terms of the speed the signal to noise was increases. And thank for watching. Thank you for the attention.
Thank you very much. And any more questions? Well,
Thanks so much.
okay, let me ask you a question. Can the results of your research being used in elaborating text-to-speech translators, especially for tonical languages, because the importance of the correctness of the translation will depend on how you pronounce and how will your microphone system percept your speech in this case. So can these results be applied in elaborating such text-to-speech translation systems?
Thanks for your question, and I understand your question. In microphone technology, in my research, interested in extracting the desired and while suppressing background noise without speech distortion. So the step speech to text is however is the next step, and I can say that my research is served for application text to speech and served at front end at front end speech application. And thanks for the attention.
So it's a very important issue with such type, with such kind of languages. Oh, okay.
Yes,
So,
yes.
And any more questions? Any more questions? Well, thank you, and we shall meet you tomorrow. Okay, thank you. And now the last one is IT slang development of Telegram chatbot.
Thank you. Let me share my presentation. Good afternoon, everyone. So first of all, would like to thank you for the opportunity to participate at the conference and present our cooperative research. And yeah, our presentation was supposed to be the first one, but actually will be the last one in the group. But I hope that the topic is not the least among the ones that have been presented today. So it's my pleasure to present an article entitled IT Slang Development of Telegram Chatbot. So this research is an interdisciplinary work and is carried out by the team from Lviv Polytechnic National University, namely, oh, sorry, I have to.
I'm sorry, Olga, I'm sorry, I switch off the microphone. So
Okay,
our guest forgot to switch off the microphone, and background voices interrupted us.
Okay, shall I start from the beginning?
Yes, I'm sorry.
Yeah,
to ask,
yeah,
but
okay.
would you do it?
Yeah, good afternoon, everyone. So first of all, I would like to thank you, the organizing committee, for the opportunity to take part in the conference and present our cooperative research. And indeed, our presentation was supposed to be the first one, but will be the last one in the group. But I hope that the topic is not the least among those that have been presented at the conference today. So it's my pleasure to present an article entitled IT Slang Development of Telegram Chatbot. This research is an interdisciplinary work and is carried out by the team from Lviv Polytechnic National University, namely Anastasia Medvedek, Mykola Lohoida, Zoriana Rybchak, and Olga Kulina. We intend to cover the following notions in today's agenda: as background information, research methods, discussions, results, and conclusions. So let me start by giving you some background information. Computer slang gives specialists in the field a sense of belonging to a close society and acts as a basic form of communication. The advent of computer technology and its impact on modern society caused this language phenomena. As a result, both IT employees and people outside computer field use computer slang. IT slang is extremely popular among programmers, developers, web designers, and other IT specialists in Ukraine. There is a lack of research on Ukrainian IT slang, as this industry to some extent is rather new for our country, and new slangs have been coining constantly. Therefore, the Ukrainian IT market is full of slang terms that are incomprehensible to ordinary people, especially those who do not speak English. In view of all this research will contribute to the study of Ukrainian IT slang with the aim to develop a Telegram chatbot. So let's move on to the research methods. Fuzzy matching and spacing have been implemented when developing the chatbot. The aim is to provide an effective execution and perform language processing. Fuzzy matching is a technique that identifies two elements of text, strings, or entities. The condition is that they are approximately similar, but not exactly the same. This technique is used in computer-assisted translation as a special case of a record linkage. In order to find correlations between segments, both text and entities, in the database and of an earlier translation. And the second method is Spacy, is an open source software library which can support natural language processing tasks. They include tokenization, part of speech tagging, named entity recognition, text classification, lemmatization, and dependency parsing. Natural language processing is becoming very popular nowadays as it ensures with easier interaction with machines compared to the communication with people. The chatbot is creating using a cross-platform Node.js and an open source platform, MongoDB. Node.js is used to create services that require constant exchange of data with the user, social networks, chatbots, online text editors, and so on. It is a cross-platform which allows JavaScript code to be run outside any browser. JavaScript performs works on the client website and Node.js on the server, which allows the latter to create applications without the involvement of other programming languages. Node.js has got some essential feature works with internal libraries, runs commands in JavaScript code, as well as is used as a web server. Another great advantage of it is a parallel execution of code, which does not block the execution of other processes. So at the same time, MongoDB is an open source cross-platform document-oriented database program that doesn't require a rigid predefined schema. This allows MongoDB to run much faster, scale better, and allow applications to increase their performance. MongoDB supports the JavaScript object notation file storage format, which effectively uses data with the complex structure. I would like to expand on to the main functions of the program. And these functions are to search for a word, its meaning and translation, to classify IT slang by parts of speech, and as well as to search for slang by categories. And here we included 3 categories: noun, adjective, and verb. So the chatbot has the following features. The first one, the chatbot system works as an application and only one user can access it at a time. The second feature is that the chatbot can work on any gadget or device, provided that the mobile application, web version or PC version of Telegram Messenger is installed. The third one is that the input data is a search slang selected or entered by the user. The output data is information on the interpretation and translation of a slang word. And the last one, that the database serves users all previous messages and shows the current stage.
I'm sorry.
So
I'm sorry. Sorry, interrupting you. Will you do you scroll your presentation, because we can see only the start frame of your presentation?
Yeah, why? I was changing the slides all the time. Yeah, so maybe I will stop and do screen sharing. Yeah, so if I'm changing,
yes,
does it work or not?
Yes, it works fine.
Yeah, I can't imagine why, because I did the same. Yeah, so I think I'm here now. So terribly sorry for that. So the significance of this, that the Ukrainian is the host language of the chat box, as the target audience is Ukrainian users. It generates communication in Ukrainian through text, and also it can review past interactions and frame new responses in context. I would like to illustrate you by showing how to get started. After that, the chatbot indicates a slang in Ukrainian, its English variant, a brief interpretation of the slang, and a translation of one is available for the verb. So it serves as a response to changing needs and rising expectations, reduce customer wait time, and provide immediate answer. And at the same time, it offers customer 24/7 support. The interaction is also easier because customers don't have to fill out forms and waste time searching for answers within the content. So then there is another option. The chatbot prompts you to enter the word, the next word to search, and you also can use the category option. So to go to the category option by part of speech, the user has to click the function view list of categories. Then they can choose the category noun, adjective, verb, and then they click back. So this chatbot is decision tree hierarchies presented to the user in the form of buttons. It reminds the automated phone menu, which we interact on a daily basis and require the user to make selections to find the ultimate answer. This process is shown on the screen here. So we have to remember that the idea of creating a Telegram chat box is rooted in the lack of dictionaries and other resources that would collect current slang words in IT industry, their meaning and translation. In conclusion, let me sum up my main points. So the chatbot was created using the Node.js platform, which executes JavaScript code, and MongoDB non-relational document database, which simplifies that database management. Thank you very much for your attention.
Thank you.
Yeah, and one more time, I'm terribly sorry for that the slides didn't change.
No mind. Okay, if anyone has question, you are welcome to ask. So, any more questions? Irina, you're welcome.
Thank you. Sorry, I have a small question. How many words there is in your dictionary IT slang?
Yeah, so we have 289 units, but they can be added anytime.
So who does help you from this dictionary?
Yeah,
IT specialists or not?
Yeah, indeed. This research has the prior research based on linguistics, where we investigated. Yeah, I'm a linguist myself. So, and I already mentioned that it's a group of interdisciplinary specialists. So first, it was a linguistic research. We created a poll among the IT specialists in order to collect the words, the sample of slang vocabulary. And based on the vocabularies that we collected, we implemented the second stage as to develop an IT chatbot, Telegram chatbot.
Thank you very much for your answer.
Yeah, you're welcome.
Any other questions, please? Well, if there is no more questions, I'd like to thank you to all of the participants for your interesting reports. Thank you for finding time to present a report, your own know-how, the last achievements in computational linguistics. And our workshop will continue working tomorrow, beginning from 9 o'clock in the morning. So, and those who have also presented their reports, I also invite for the second half of the workshop for tomorrow at 9 o'clock. So, and I switch off the record, and you can